This video will be a guide on how to graph quadratic functions given an equation and a table of values. All right, let's look at example 1. We have the equation y equals 1/2 x squared minus 2, and we have a table of values with x values ranging from -2 to +2. From our understanding of how to evaluate, we should know that when we are given x values, we can input them into the equation whenever we see an x. So since we're given 5 distinct x values, we need to input to get 5 distinct y values or 5 y values. All right, so let's write down what that looks like. So for our first x value, we have -2. If you rewrite the equation, remember to leave parentheses whenever you see an x. So I have 1/2 x squared minus 2. And then inside of the parentheses, I'm going to put the value of x that I'm looking for, or that I'm given, which is -2. All right. From here, once you input this into your calculator or you do the mental math, you should get a corresponding y value of 0. All right. Depending on how you like to work, I like to take my ordered pair and plot it on the coordinate plane. So we can do example 1 like that. Remember, our coordinate plane is made up of an x and y axis. So the first ordered pair that we have is -2 in the x and 0 in the y. So I'm going to travel -2 in the x and 0 in the y to land myself right there. All right, so I got my first point done. Now I'm going to move on to the next x value of -1. The process does not change even though the number changes. So the first step is to rewrite the expression, but without an x value, you're going to put parentheses. And then inside of those parentheses, once again, you're going to put the given x value that they give us. This time they give us -1. So I'm going to put -1 right inside of those parentheses. There we go. So once you put that in, you should get a corresponding value of -1.5. It should give you -3/2 if you like fractions, but whenever we talk about plotting things on the coordinate plane, it's best to keep them in a decimal. We can kind of estimate decimals or eyeball decimals better than we can fractions. All right, so I'm going to continue this process all the way down for 0, 1, and 2, and you should do the same. To get ahead of my work, I do like to pre-fill them or create what I like to call skeletons all the way down so that I don't have to constantly go back to rewriting the equation. So I wrote the equation all the way down, and then I will go through and fill in the skeleton wherever I see my parentheses with the given x that I need to find a y value for. So first I got 0, then I got 1 and 2. 0, 1, and 2. And then once you put each of those in your calculator separately, or you do the math for each of them, for 0, you should have gotten -2 for the y. For 1, you should have gotten -1.5. And then for 2, you should have gotten 0. All right, and then from here, since you notice I've only plotted the first ordered pair, now is where you would come back and plot the rest of the ordered pairs. Please take your time when you're plotting these. So next we have -1 in the x and -1.5 in the y. So if we go -1 in the x and -1.5, is kind of in between -1 and 2. So right there. And then next I have 0 in the x and -2 in the y, which will land me right there. Next, I have 1 in the x and -1.5 in the y, which is right there. And then lastly, I have 2 in the x and 0 in the y. All right, so we have 5 ordered pairs all plotted. And if you notice, they create this U-like shape. This U-like shape is what is called a parabola. So if we connect the dots, We'll create this U. From our understanding of continuous functions, remember we can draw arrows because this will keep going if we had enough space. So there we have it. It's a little botchy. It's not supposed to be a V at the bottom. It's supposed to be more curved. And if you have a graphing calculator, you can check that in your graphing calculator to make sure our sketch looks similar to what the equation should look like. All right, so that's example 1. Let's move on to example 2. All right, example 2, we're given the equation y equals x squared minus 2x minus 3, and then we're still given the same table of values in hopes to be able to create a quadratic graph or a parabola. The reason why I want to cover this example is because if you notice, when you are substituting or evaluating for your x values, you're going to have to input twice. So if they give you more than one x, yes, you have to put it into your equation twice. What do I mean by that? Let's look at what will happen with negative 2. All right, so we have y equals, instead of x, I'm going to put some parentheses, squared, minus, instead of 2, well, I'm going to leave 2. I'm going to put parentheses instead of that, x minus 3. And then I'm going to highlight the parentheses so you guys can see where I was coming from. And then inside of those parentheses for this very first set of values, or this very first set of ordered pairs, we're going to input negative 2. Negative 2. All right, so make sure that you take your time, that you input them in twice, or input them in whenever you see an x. And when you do that, you should get at a corresponding y value of 5. All right, if you liked my method of pre-filling last time, I suggest you do that. So now I'm going to input negative 1. So I'm going to write the parentheses, square minus 2 parentheses instead of x for my negative 1. And then I have minus 3. And then inside the parentheses goes negative 1. Negative 1. I love to highlight because it keeps you on track. You know exactly where your numbers came from and where they're going. And then once you put that in, you should get out a corresponding value of 0. All right, moving along. So I'm going to go ahead and fill out all of these all the way down. Like I said, it's just mathematicians, we like to speed things up a little bit if at all possible. So this will help out your process. All right, and so next, my next value to input is 0. So I'm going to input 0 into this third row, keeping my highlights going. When you input 0, you should get a y value of negative 3. Next, I'm going to input 1. Once you input 1 into your equation, you should get negative 4. And then lastly, I'm going to input 2 into my equation. Once you input 2, you should get out a value of negative 3. All right, now that we have all of our ordered pairs, just as we did with example 1, we're going to plot these on the coordinate plane to see what the graph of our quadratic function looks like. So first we have negative 2 on the x and 5 on the y. That lands me right there. Then I have negative 1 in the x and 0 in the y, which lands me right there. Next I have 0 in the x and negative 3 in the y. 1, negative 4, and lastly 2, negative 3. Okay, if you take your pencil and you go ahead and connect your dots to create your sketch, you'll notice that it's like you have an incomplete parabola, but one unique feature that a parabola has is that it is symmetric. So about what's called this center point, you'll learn more about vocabulary in a minute, but this center point here creates symmetry for your parabola. And what I mean by that is, what you see on the left side, you will see on the right side. And you can kind of see the symmetry about the values of the y values that you get out once you input them. So I know it looks like half of the parabola, but if you could take an educated guess or continue to input values, you can probably guess that this will be a point on your parabola, and you can continue your line through it. Remember, when we do these on paper, these are just sketches. Your graphing calculator will give you a much more accurate depiction of what the function looks like. We just need to know where it's at and some points on it. All right, moving on to the very last example, example 3. All right, example 3 is yet again another quadratic equation, y equals negative x squared, and we have the same table of values. One thing I want to mention, once you move on to independent practice, you do not have to keep the same table of values. These are just standard table of values. They're easy numbers to think of really quickly. But if you want to do -5, -4, -3, -2, you can do those values as well. All right, so the last equation, I'm going to be super repetitive to make sure that we all got this down pat. Whenever you are given x values and you are given an equation, you can input, substitute, or evaluate them into the equation. They're all the same thing. So first I got y equals negative. Instead of the x, there goes some parentheses and square. And because I mentioned this on the other two examples, I'm going to go ahead and pre-fill in my skeleton of what I want to substitute so that I don't have to keep rewriting it. All right, and then now I'm going to go back through and actually input, and it also actually helps to highlight. This one is a little bit easier because it's only one place that you're substituting, and it's right there, but it still helps to highlight. All right, first when you input -2, please be careful. -2 does go on the inside of the parentheses. Examples like this is the reason why we do use parentheses, to make sure that your final answer has the correct sign. You should get -4. When you input in -1, you should get out -1. When you input in 0, you should get out 0. When you input +1, you should get out -1. And then when you input +2, you should get out -4. Looking at these y values, hopefully we can see that the values are symmetric about this center point of 0. So let's plot them to see what that actual graph looks like. So we got our x and y axis. First up is -2 in the x and -4 in the y, which lands me down here. Next up, I have -1 in the x and -1 in the y, which lands me there. Then I have 0, 0 in the origin. Then I have 1, -1, and then finally 2, -4. Look at those beautiful symmetric points. You're going to take your pencil and connect the dots to create what is called a parabola, this U-like shape. We can draw some arrows at the end. All right, hopefully this video better explains how to graph quadratic equations given a table of values.